right, we're going to start with basic math. Now, this section is 25% of the exam, so you can expect to see somewhere between 11 and 12 questions of this type. A lot of the first 6 questions on the GED test are going to come from this section right here, what we're about to do. The first 6 questions are special because you're not allowed to use a calculator for those first 6 questions. The remaining 40 questions on the GED test, you are. So out of these 11 or 12 basic math questions, probably a good chunk of them will show up in the non-calculator section. Evaluate -10 to the second power. So this one, if you plug this in your calculator, as it is right here, you're going to get A, which is the correct answer. Because what it's going to do, or the way that you would read this, is not -10 times -10, which is what an exponent does, is it takes whatever it's connected to, and you multiply that number times itself that many times. Instead, this is going to follow order of operations and exponents come before multiplication. So this is actually interpreted as 10 squared. Then you take that answer and times it by -1. Kind of strange, but it's almost like this is interpreted as -1 times 10 squared. Is kind of how that plays out. So you would do 10 squared first, then times the answer by -1, which is why A is going to be the correct answer here. If you wanted to do -10 times -10, it would need to look like this on your test. That would be how you indicate when you want to include the negative symbol with the calculation of the exponent. That would actually mean -10 times -10, which would have the outcome of +100. But you'll notice again that that's not how they write the question. Which of the following is equivalent to 32 3/8 plus 9 3/4? All right, so we're adding two what are called mixed numbers, a mixture or a combination of a whole number component and a fraction component. So 32 3/8. Now, when it comes to adding mixed numbers, the first place your eyes want to go, and this could be adding or subtracting, is you want to focus on the fraction parts, and even more specifically on the bottom number of the fractions. You need that bottom number, which is also called the denominator, to be the same. It needs to be the same fraction size. Because I can see here that 4 and 8, that 8 happens to be a multiple of 4, which is just 4 times 2, I can just quickly multiply the top and the bottom number by 2 in the second fraction, and that will give me 6/8, which is going to be a fraction of the same size. 6/8 has the same size now, 8 and 8. That allows us to add them. And so when it comes to adding, we focus on the top numbers, 3 and 6/8. 8 fits into 9 one time with a remainder of 1. So we turn that into a mixed number. 8 goes into 9 one time with a remainder of 1. So it becomes 1 and 1/8. And now focus on the whole number components, the 32, the 9, and this 1 over here. And we need to add those numbers together now as my whole number, and 1/8 as the fraction part of it, which matches to answer choice A. Joseph weighs 270 pounds. He goes on a diet and loses 15% of his body weight. How much weight in ounces did he lose? What we need to do, what I'm going to choose to do, is change this pounds number into ounces using this scale factor right here. And then from that, I'm going to have this total ounces. I'm going to figure out 15% of that. So 270 pounds times 16 ounces means he weighs 4,320 ounces. If I take 15% of that, I would just times it by 0.15, because when you're working with percents, you need to change the if it has a percent symbol beyond it, like it does here, it says 15 and it has a percent symbol. That percent symbol literally means out of 100. So 15% means 15 out of 100. And we get 648. So that's how much he lost. How much weight in ounces did he lose? So 648 is A. Okay, so now we are going to calculate this by hand and just following the same steps I did with the calculator. So 270 times 16. 6 times 0 is 0. 6 times 7 is 42. And that's 16. 1 times 0 is 0. 7 and 2. Add these together. You get 4320. We're going to then times that by 0.15. Carry a 0. Add these together. Move the decimal place 2 places to the right there. And then we need to reflect that by moving it 2 places to the left. Whoops. 2 places to the left down here. So 648. Jackson brings $50 to a casino. Throughout the night, he wins $100, then loses $130, and then finally wins $10. How much does he leave the casino with? Okay. We could do this a number of different ways. The first thing I'm thinking of is I want to figure out what his net gains or losses are, and then compare that to what he brings to the casino. So if he wins 100, loses 130, he's lost $30, and he finally wins $10 back, so he's lost $20 ultimately. So 50 minus 20 is 30. Now you could also just do 50 plus 100 minus 130 plus 10. Okay, next question. Which of the following lists the values from least to greatest? And we have 5 values there. 3 of them are fractions and 2 of them are decimals. The approach to this question ought to be first get them all into decimals so that we can compare from there. On the top number of the fraction, add a 0. And then ask yourself, how many times does 7 go into 20? So 2 and 6/7. Then you put a decimal right there. Now, how many times does 7 go into 60? We repeat that, put a 0 up there. So 7 times 8 is 56. So it goes 8 times with the remainder of 4. And what you've just done right there is you've just built the next digit. Then you can do it again. So I'll just erase this. It goes 5 times with the remainder of 5. So the next digit is going to be a 5 with a remainder of 5. So you can keep on doing that over and over and over again until you get as many digits as you're comfortable with. Now, 8/3, what I would suggest doing with that one is first turning it into an improper fraction, or a mixed number, turning it into a mixed number. So 3 goes into 8 2 times with a remainder of 2. So that is 2 2/3. Now that might be enough information that you don't have to go any further than that, because it's basically 2 as a whole number, and then the fraction or the decimal part of it beyond the decimal is going to be dictated by 2/3. But just so you can see what it would look like if I continue to go on, I would then go like this. I'll put a 2 point, and then I need to add a 0 here to this 20, or to make it 20. And 3 goes into 20 6 times with the remainder of 2. And see how we get the same fraction that we had started with, 2 over 3. So if I add another 0 to that, it would be 3 goes into 20 6 times. 3 goes into 20 6 times with the remainder of 2. And it's basically going to repeat over and over again. So it's going to be 2.66 repeating. So 13 over 2. First, let's change it into a mixed number. So 2 goes into 13 6 times with the remainder of 1. So 6 and 1/2. Okay, and now you might already know that 1/2 is, you probably already know that 1/2 is 0.5, but if we needed to, we could do this method, put a 0 at the top, and 2 goes into 10 5 times with no remainder. So 5 times with no remainder. Anytime you have no remainder, that decimal just stops right there. Least to greatest. Well, the least number I can see already is going to be this one down here, which was 2 over 7, which is 0.285. That's smaller than 0.658. So now note in the answer choices, it uses the original fraction and not the decimal that we calculated there. So 2 over 7 should be the very first one listed. So already we can narrow this down to either A or B. Now the next difference comes from the third one in. It's either 1.3 or 8 over 3 that's bigger. So 8 over 3, we calculated, that was this one right here, 2.6 repeating, or 2 2/3 also was where we said, I said you might be able to end right there. You may not have to go any further than that after you change it to a mixed number. And it turns out that we could have just left it as a mixed number like that, and that would have been enough information without even having to do any of this other stuff here. Because 2 2/3, the whole number 2, is bigger than the whole number that that we're comparing it with in the answer choices provided. So clearly 1.3 is going to be smaller than 2 point anything. So A has to be the answer because 1.3 has to be smaller than 2 point anything, which is 8 over 3. So A has to be the answer there. Use the rules of exponents to simplify the expression m to the negative 5th power times m to the 6th power. Immediately, I know that this is going to be m to the 1st power because I know that I'm multiplying two things together that have the same base or the same big number. In this case, it's m. If we're multiplying with the same base, then you add the exponents together. So negative 5 plus 6 is 1. And m, just plain old m, is also m to the 1st power. So that is B. Okay, so we just saw there how knowing the rules for exponents can help you answer this very quickly. So I want to demonstrate the 3 exponent rules that you're going to need to know for the GED test, and I'm going to demonstrate them using actual numbers instead of letters. So I'm going to do, let's say, 3 to the 7th power times 3 to the 2nd power. Then I'm going to do 3 to the 7th power divided by 3 to the 2nd power. Then I'm going to do 3 to the 7th power raised to the 2nd power, like that. So the first one is multiplying with the same number, the same big number, in this case is the 3. In that case, you add 7 plus 2, so that'll be 3 to the 9th power. The second one, when you're dividing, you do the exact opposite of adding, which is subtracting. Top number minus the bottom number. So that's going to be 7 minus 2 in that order. 3 to the 5th power. Now the final one, when you have two exponents kind of like back to back like that without anything in between it except for parentheses, you multiply those. So this is going to be 3 to the 14th power, 7 times 2. A 10-pound bag of cherries costs $34.50. How much does each pound of cherries cost? Okay, this is a division question. We have a total cost, $34.50, for 10 pounds. So how much does 1 pound cost? Anytime you're dividing by 10, you're just moving that decimal point one place to the left. So this will be $3.45. Which of the following values of x makes the expression undefined? And we have a fraction here with some algebra language involved using letters and things like that. So undefined means that there's no answer or that it's impossible to do. There is a type of fraction which is impossible to do. And fractions is just another way of showing division. So let me explain what I mean by that. Any division question can be rewritten as a multiplication question like so. Or 10 divided by 5 is equal to 2 because 2 times 5 is equal to 10. So you see how you can just reverse the order. Reverse the operation from divide to multiply and reverse the order, and you'll come up with two statements which are true. Now, if we try this with 0, something weird happens. And I just already said it right there. 0 is the number we're not allowed to divide by because this is what happens. So 10 divided by 0 equals question mark. And if this was possible, we should be able to take that same question mark number, times it by 0, and have it equal to 10 because we're just reversing the order of all those digits, right? Just like we did on the top one. 10 divided by 0 equals blank, and that same number, blank, times 0 must also equal 10. Well, you know that anything times 0 is equal to 0. So this is an impossible scenario. Anything times 0 is 0 because when you times by 0, you're basically saying 0 groups of whatever number it is. So 9 times 0 is 0 because it's 0 groups of 9. So there's no number that you can multiply by 0 to get to anything other than 0. So therefore, this is an impossible situation. And the reason it turned out to be impossible is because we were attempting to divide by 0. So this must also be impossible. Now, in math, impossible is the fancy word for impossible is undefined. So now I want to demonstrate this, what they're asking with with a more simple scenario. Let's just say 8 divided by x. And the same question applies. Which of what following value of x makes this expression 8 over x undefined? The answer would be 0. It would look a little bit more, if I wanted to be more official about it, it would look like this. X is not allowed to equal 0. So the equal sign with a slash through it. X cannot equal 0 because if it did, the fraction would be undefined, and that's impossible. So see, that's what we're kind of looking for in this question, is asking us, what is this? What is this number that x is not allowed to equal? So you can see there, it's kind of like a backwards kind of question. It's like, what is x not allowed to equal rather than what is x equal to? If x was 1, then 1 squared is 1 minus x. If x is 1, then you're just doing minus 1. So 1 minus 1 would result in 0. So 1 is not allowed. The number 1, it would result in an undefined fraction. Which expressions are equivalent to -3 times 4 plus 7? Drag and drop the expressions to the correct location. So 4 plus 7, and think order of operations, do your grouping symbols or parentheses first. 4 plus 7 is 11, and 11 times -3 is -33. So this is actually equal to -33. 12 minus 21, nope. -12 plus 7, nope. -12 plus -21, that is good. -12 plus 21, nope. Negative 12 minus negative 21. Nope. Negative 12 minus 21. Yes. Okay. A model house is 22 meters wide. If it was built with a scale of 1.1 centimeters equals 2 meters, how wide is the actual house? Okay, so we have a question here that involves a scale or a scale factor, sometimes it's called. Anytime you have, as part of the instructions, some sort of scale, like 1 mile equals 5,280 feet, or 1 foot is equal to 12 inches, anything like that, you can use proportions to solve the question. And a proportion is where you have two fractions that are equal to each other, and then you cross multiply and divide to figure out the missing number. So using a proportion in this question would look like this. 1.1 centimeters over 2 meters. So start with the thing that they give you as the scale is equal to 22 centimeters over blank meters, which is our answer. And now we cross multiply and divide. But before I get to that, I want to take a moment at this point and give you a suggestion. When you're dealing with proportions or fractions in general, something you want to be mindful of is that fractions should never contain other fractions within it, and fractions should never contain decimals within it. In this case, we have a decimal on the top of a fraction. It's kind of like bad math grammar, and it's just not very pleasant to work with. So if there's a decimal within a fraction, we got to deal with that. And essentially dealing with it means multiplying the top number and the bottom number of the fraction by 10 over and over and over again until all the decimals are eliminated. So if we multiply 1.1 times 10 on the top, if we do times 10, multiplying by 10 means we move that decimal one place to the right. Multiplying by 10 on the bottom means we move where the decimal would be to the right one place and becomes 20. So instead of 1.1 over 2, it becomes 11 over 20. So we need to match up diagonally 20 times 22 and then divide by the number that's not used yet, which in this case is the 11. 11 goes into 44 4 times perfectly, by the way, perfectly, and then we can add the extra 0. So 40. So this answer is 40.